Saturn's enigmatic rings. A journey through time and space. Delve into the captivating history of Saturn's iconic ring system, from Galileo's mistaken moons to modern spacecraft revelations. The science behind its 27-degree tilt, intricate divisions, and mysterious gaps. Join us as we explore the icy particles ranging from sand to boulders that compose these celestial wonders. Saturn, the sixth planet from the Sun, is one of the easiest targets for astronomers to identify. Owing to its huge and conspicuous ring system, Saturn's rings have captivated astronomers for centuries, ever since telescopes were first aimed toward the sky. When Galileo Galilei first glimpsed Saturn in 1610, he mistook the rings for massive moons, one on each side of the planet. Over the course of several years of monitoring, he noticed that the rings changed shape and even disappeared when their inclination with respect to Earth varied. We now know Galileo witnessed a ring plane crossing. Saturn's equator is 27 degrees inclined relative to its orbit around the Sun, which is identical to Earth's 23-degree tilt. Saturn's hemispheres are turned sunward as it orbits the Sun, first one, then the other. Seasons are caused by Saturn's tilt, exactly as they are on Earth, and when Saturn reaches equinox, its equator and ring plane are directly in line with the Sun. The Sun shines directly on the rings, making it impossible to see the tiny line between them. The rings are 170,000 miles or 273,600 kilometers across, but just around 30 feet or 10 meters thick. Christian Huygens, an astronomer, proposed in 1655 that the unusual bodies were solid, inclined rings, and another astronomer proposed in 1660 that the rings were made up of little satellites, an insight that was not validated for nearly 200 years. Pioneer 11 was the first spacecraft to fly through Saturn's ring plane in 1979. Voyager 1 and Voyager 2 saw the planet's ring system in the 1980s. NASA's Cassini-Huygens mission became the first to reach orbit around Saturn in 2004, providing thorough measurements of both the planet and its rings. Structure and composition. The rings of Saturn are composed of billions of particles, the smallest of which are the size of grains of sand, and the largest of which are boulders the size of mountains. Rock-like meteoroids that are traveling through space are drawn to the rings because the majority of their composition is made up of water ice. When observed through the eyes of an inexperienced astronomer, Saturn appears to be encircled by a solitary continuous ring. On the other hand, there are several other divisions. The names of the rings are listed in alphabetical order according to the order in which they were found. As a direct consequence of this, the three primary rings are labeled A, B, and C, going from most remote to most accessible. The A and B rings are split by a region known as the Cassini division, which has a width of 2920 miles and 4,700 kilometers. The advancement of telescope technology has led to the discovery of additional rings that are less bright. In 1980, the Voyager 1 spacecraft made the discovery of the D ring's innermost portion. The A ring is adjacent to the F ring, but the G and D rings are located a considerable distance apart. The rings themselves are composed of a variety of structures and gaps. Some of them are thought to be created by the numerous minor moons that orbit Saturn, while others continue to baffle astronomers. Saturn is not the only planet in the solar system with rings. Jupiter, Uranus, and Neptune all have small ring systems. However, Saturn's ring system is by far the largest and most visible, with satellites reaching 3/4 of the distance between Earth and the Moon, 175,000 miles or 282,000 kilometers. Although Saturn is not the only planet in the solar system with rings, it is by far the largest and most visible. Theories of the genesis of things. There are a few different hypotheses that attempt to explain how Saturn's rings came to be. Some researchers in the scientific community are of the opinion that the planet's gravity was responsible for the capture and fragmentation of any comets or asteroids that were in its path. According to a different hypothesis, the rings were formerly gigantic moons that collided with Earth in a catastrophic event. Saturn is orbited by at least 62 moons. Titan is the only one of the four to possess a large body. The others all have little bodies. Only 13 of the moons have diameters that are bigger than 50 kilometers or 30 miles. The gravitational pull of these moons has an impact on the configuration of Saturn's rings, but it also reveals insights into the processes that may have been involved in their development. So that is it for this video. Subscribe if you want to watch more.